All right, let's do another one. How's your day been? Has it been all right? I hope it has. I hope it has. My day's been all right. It's been okay. If I'm still smiling, it can't have been that bad. All right, so this is going to be like kind of like a storybook combining like terms. Let me just get you going on a few of these points about combining like terms. So let's bring it all the way back. Oh, yeah. Okay, I'm going to say, hey, let's bring it back. And then you got to say how far back. All right, so here we go. Let's bring it back. Way back. To when you first learned to add things. So 5 plus 2. Now the reason you can combine 5 plus 2 is because fundamentally you know how many ones are in a 5. Right? It's 5 ones. And you know how many ones are in a 2. So that's why you could say, oh, okay, well that's 7. Perfect. And then you can also do subtraction as well. Okay, so, and you can keep going. I mean, I could add another value. I could add a 3. And you're like, oh, no, you almost fell off your seat. You're like, dang, he's going to add 3? Oh my God, this guy's crazy. This guy's adding 3. Right? And you can say, oh, okay, well that's 10. And so you can combine them all because fundamentally we know how many ones go into a number. So you can add these integers all day long, okay? Let's complicate it just a little bit. Now let's go 5 plus x. Well, now you say, okay, so what's 5 plus x? Well, it's just 5 plus x. You can't simplify that any further. And because fundamentally, again, we know that 5 is 5 ones, but I don't know how many ones go into an x. I don't know. I'm not sure. And so they don't have the same counting unit. So you'll never be able to add these two things together. It's just 5 and some x's. In fact, there's just one of them. And so it's kind of a different counting unit. And so you'll never be able to combine these terms. Okay, you following? Let's do 3x. Now again, I still don't know how many ones go into an x. But this number here is now kind of special because, and if I switch its color to say pink there, what it's doing is it's telling me how many of those x's I got. Because I know that 3x, where's the blue marker there, is x, x, and x. It's literally 3 x's, right? I mean, 3 times x, if I was to rewrite it up here, 3 times x is going to be x plus x plus x. You know, or it's 3 plus dot, dot, dot. So it depends. You know, it's either one. Because 5 times 4 is the same as 4 times 5. But maybe that, I don't know if that was helpful or not. So I'm going to erase that. Okay, so again, I can't combine it with the 5, but look at here. You see, I know that that's 1x. I still don't know how the hell many ones it is, but I know how many x's it is. And so really what like terms are, it's like a shared counting unit. Like I know I got 4 x's. And so you can combine these. You feel that? You feel that? All right, so let's keep going here. Let's keep it going. So let's go 5 plus 4x. And let's just assume maybe we were going to add an x squared. Almost to the end of the story. I'm not going to go too far into the story. It's funny, in my mind, I'm still hearing that lovely music that I was playing on the way in. Is that music still going? Yeah, I was still hearing that in the back of my head. So periodically, you see me dance a little bit. I'm still hearing that lovely music. I'll put it in a video so you can link to it. All right. So again, you know where I'm going with this, right? 5 is 5 ones. Okay, 4x. I don't know how many ones, but I know there's 4 x's. Now, x squared. You don't know how many x's are in an x squared. You don't know that. There's x number of x's. It's like if you did 5 squared, right? There's 5 5s, and that's 25, right? So there's 5 5s and 25. But if it were 6 squared, well, there would be 6 6s in 6 squared. And so we don't know how many x's are in x squared. It depends on how big x is. And so again, we have this situation where we have a new counting unit. And we'll never combine these two because fundamentally, we can't say. It actually depends on the value of x. If I knew x was like the number 4, then cash money, I'll combine them all together at that point. So you just got to kind of settle on the fact that when the terms are different, that you can't combine them. Because the act of combining is always an act of asking yourself, how many of these things do I have? That's the plus sign. It's not multiplication. This is adding. How many ones do I got? I got 5 of them. How many x's? I got 4 of them. How many x squares? I got 1 of them. Now, what if we did this? Oh, come on. You know where I'm going with this now. Just say you know where I'm going with it. Mr. Miller, I know where you're going with this. It ain't rocket science right now, Mr. Miller. See, now you can add these because they're all x squareds. And so when we talk about like terms, what we talk about is that the base and the exponent have to be the same. The base is the thing that carries the exponent. And so if the base and the exponent are the same, like here, then you can add or subtract them. This number is the coefficient. And so it doesn't really matter that it doesn't have an exponent because it's only telling you how many of those you've got. And so at this point, if we trip this problem out, because in the back of your mind, by the way, this equals 6x squared, right? 1 plus 5, you got 6. I think we're almost to the end, but look at this. What if we rocked it like here? Like m(n) to the 7th, something like totally strange, right? And really kind of not practical. But in this case, it's a mental exercise for us. And then we said plus 3mn, say to the third, let's put the third there. And then we'll say plus 5mn to the 7th. I need to get a quick check on the time. Oh, I got 4 minutes. Okay, well, I only need 4 minutes. So what we got then is the term is here. Because it's multiplication, see, it's separated by addition and subtraction. So I've got one of these. I got one term that's m times n to the 7th. And over here, I've got 5 of them, right? I mean, you could put a 1 there. And so the coefficient, which is the number being multiplied by the variables, tells you how many of that variable situation you've got. And so here, I've got 6 m n to the 7th, right? Because that's 1 m n to the 7th. And this is 5 m n to the 7th. So, you know, m n to the 7th isn't this crazy variable that you probably see in nature or something. I know it's kind of strange to the 7th power, but now this is a different one, you know, because it is m to the 3rd n. So I don't have any other ones of that. So I'll never be able to add these two together. And so it would be this. This would be the correct final answer. And I did adding, but subtracting works the same way. You can add and subtract. So combining like terms is always about adding, right? Now adding or subtracting, but to remember to subtract is to add the opposite, all right? So it's about counting. Oh, that's a better word. Oh, it's about counting. Combining like terms is about counting how many of each term you got. That's your goal. How many of each term you got? Oh, come on, player. Give me some of that music there to bring us out. When I started the video, I said, I hope you're having a good day. I hope it's still true.